In this case study, you will perform the buckling analysis of a long beam, as shown in fig. Determine the buckling load or critical load when the beam starts buckling. The beam is fixed at bottom end and a load of 14,000 Newton is compressive axial load is applied to its top face. The beam is made up of AISI 304 steel materials. So first of all, download this beam from our video description link and start a new simulation study of Solidworks. Make a new simulation study and give it a specific name, that is buckling of beam. Ensure that buckling from advanced simulation is selected. Okay. Now go to the cut list and apply material, that is AISI 304 steel. Select 304 steel material, apply and close. If you right click on this beam element, go to the edit destination and ensure that beam is selected, not the truss. So beam has already been selected. Close it. You can see there are two joints, two ends, because a beam has two ends. This is start end and this is its top end. Just go to the fixtures and from here you will select the joints or its bottom end. Okay. Then apply a load of 14,000 Newton on this joint, not on this face. Force, select this joint option, select the joint and select the directions. Load should be normal along the in front plane. Not this option. Yes. Enter the value of 14,000 Newton and change its direction. From buckling study, go to properties and change the number of mod shape to 3. Okay, just run your simulation study now and wait until your simulation study completes. So our simulation has been completed now. You can see the buckling load factor for first mod is 0.5733. That is less than 1. That means this beam under this loading will go in buckling. If you click on you can animate its deformation behavior. It will be like that. So buckling load factor for first mod is 0.57. If we click on the results and list buckling factor of safety. So For first mod is 0.57 and for second is 5.1 and then 3. So buckling is occurring at its first mod. So what will be the critical load? Let's start buckling. We will multiply this buckling load factor to the applied load. So open the calculator. Multiply 4000 Newton by buckling load factor. 7,980 Newton is the buckling load or critical load at which beam start buckle. So this is the method how we can determine the starting buckling load if our buckling load factor is less than 1. I hope you understand the concept of this simulation study. Please make a practice of this tutorial. Thank you for watching this video.